Hello guys, welcome back to my YouTube channel. My name is Yasser Ahmed. So in this video, we're going to be looking at Chapter 2 from the ICT IGCSE course, Input and Output Devices. We're going to be focusing on 2.1 in this video, and we'll check out the other parts of this chapter in the next set of videos. So 2.1 is Input Devices and their uses. So let's have a look at this little diagram here. So we have input devices. It could be a mouse, joystick, a microphone, and a keyboard. So an input device is used to allow data to be input into a computer system. The CPU is a processing unit which would process the information, and then the information will eventually be outputted using one of these devices. It could be a monitor, it could be a printer, it could be a speaker, it could be a projector. So output devices allow data to be outputted from a computer. So we're going to be looking at lots of different examples of input devices in this part of the video. And the first two examples are a keyboard and a numeric keypad. So a keyboard may be used in everyday use in a laptop and a desktop computer to enter letters. It could be to write a document. It could be to enter command prompts into a CLI interface. Advantage of using a keyboard is fairly easy to use, and it's a quick method of entering data. However, it's not as quick as using a direct data entry device, which we'll be looking at some points in the next part of this chapter. Numeric keypad is a lot simpler compared to a keyboard. It's not many keys. It's normally used when you were entering pins, for example, at the ATM or point of sale, or on a chip and pin device, and also mobile phones. So it's really straightforward to use as we don't have many keys to enter. However, it can be quite difficult to write letters using the numeric keypad. So on older mobile phones, you'd have to write a text message by pressing on a number a few times to get to a particular letter. So these are the pointing devices used to control the cursor on the screen, to select windows, to click icons, to select menu options, and to position a pointer. So the most familiar pointing device is the mouse. It's easy to navigate through menu options, quick to select an option compared to a keyboard. However, with a mouse, you need a flat surface, and it could be easily damaged. So the cable that connects to your desktop or laptop could get trapped or could be damaged. The touchpad is built into the laptop, and it's also used as a pointing device. So it's probably myself, if I'm being honest, I prefer to use a mouse plugged into my laptop computer because the touchpad is more difficult to use compared to a normal mouse. However, since it's part of the laptop, there's no need to purchase a separate device. The trackable is also a pointing device. It's probably more expensive and not as familiar to use. However, it's more accurate compared to using a touchpad, you could say, and is used by those who have limited motility in their wrist. So the actual trackable is not moved. What is moved is a ball at the top of the trackable, and you move the ball using your fingers. And by moving the ball, you're controlling the cursor on the screen. So here's a typical exam question. Compare and contrast the use of mouse, touchpad, and trackable as a pointing device. So the mouse is normally used with a desktop computer and is the most familiar pointing device used. However, the mouse requires a flat surface to be used and is more likely to be damaged. The touchpad is a fixed device commonly found on laptops, so it's more difficult to use compared to mouse. The trackable pointing device is used by users who have a limited motility in their wrists. Users would have to move the ball at the top of the device using their fingers to control the pointer on the screen. The trackable, however, tends to be more expensive than other pointing devices. And then we have more input devices. So the remote control can be used to control your TV channels, can be used from a distance, however, can be blocked by obstacles. The joystick can be used in games and simulators. It's easier to use to control an action in a game compared to a keyboard or a mouse. However, more difficult to use compared to a normal mouse for everyday everyday tasks, like just selecting options like this. So a joystick would be best used in a game scenario rather than a normal everyday scenario where we could use a mouse. And then obviously driving wheels we can use in a gaming context again. It's probably going to be more realistic experience using the driving wheel compared to using a keyboard or a mouse to control the direction. Um, Going to be more expensive, and the movement could be too sensitive, perhaps. So that could be adjusted. So you'll notice the use of driving wheels in simulators and used by gamers in racing driving games. So touchscreen actually doubles up as both an input and output device because the data is shown on the screen, but it's used in mobile phones, tablets, point of sales, interactive whiteboards. It's really straightforward to use and select options. However, other options could be selected accidentally and the screen could get dirty. Scanners could be used to scanning documents which could be eventually signed. Copies can be created, and the quality is dependent on the resolution of the settings. So when you scan in your document, it will be dependent on the actual scanner we're using and the quality settings that have been set. So this is useful if you want to, if you receive an email of a contract, for example, and you need to sign it and send a hard copy back. We could, the original copy of the contract could be scanned in, could be emailed, and then could be printed out, signed, and then posted off. And then obviously digital cameras are used to take pictures, record small video clips, and then that data can be transferred to computers. High resolution pictures and videos can be taken and stored on the memory cards. No need to develop any film. However, transferring, storing, and editing images can be complicated. So you'd have to connect the phone to your computer or take out the SD card and plug that into your computer. So that may take a while. And then if you want to record audio, we need to use a microphone. So obviously in these videos, I have to have an inbuilt microphone to record my audio. Okay. It can be used in voice recognition applications as well. It could be used to write out letters based on audio input. So voiceovers can be added to your presentations. Recorded audio can be typed directly into word processor applications using specific applications. However, the voice application is not as accurate as typing text into a computer. And then finally, light pens can be used in CAD applications for drawing on screen, more accurate than touchscreens, small in size, and can only be used with CRT monitors, and is quite a dated technology. So I don't think it's been used as much as it used to be. And here's a typical exam style question. Why different user interfaces require the use of different types of input devices? So with a graphical user interface, a mouse enables users to easily maneuver a pointer around the screen to select icons representing applications. Many options in Windows. The mouse can also be used to drag windows and icons across the screen. People with disabilities may prefer to use a trackball as a pointing device as they may have limited motility in their wrists. In addition, a joystick or gamepad could be used to mimic the behavior of a mouse when playing games. On the other hand, a keyboard will be required to enter command prompts into a CLI. Touch screens can be used directly to select options, normally found on portable devices such as smartphones, tablets, or even a point of sale. So this question, we're discussing why we would use different types of input devices in different scenarios. Okay, and here we have additional exam style questions. So one input device on a tablet computer is a touch screen. Name other input devices built into a tablet computer. So you could have a microphone, a camera. Some more questions. So what you can do, guys, is just pause on these questions and have a look. Fairly straightforward. Sometimes you may have to write in keywords, or you may have to tick an option. So, for example, inputting moving pictures from a fixed position into a computer. So that would be a webcam. Entering text directly into a word processing document. Keyboard. Applications where text has to be created rather than copied. So keyboard. And inputting hard copy documents directly into a computer would be a scanner. Okay, so now we're going to be looking at sensors in a little bit more detail. So role of measurement applications. So sensors are placed to measure physical variables. The data from sensors are measured in analog. The analog signal is then converted into a digital signal using a converter. So here we have different types of sensors that could be used. So sensors So the first one is temperature. We could use it to control a central heating system to maintain a particular temperature. Moisture, humidity. So this could be used in a greenhouse to monitor the moisture levels in the soil or the humidity in the greenhouse. So light sensors could be used to switch on and off street lighting. It could be used to switch on the headlights in the car when it gets dark. Infrared or motion could detect intruders in a burglar alarm system or count people leaving or entering a building. Pressure could be used to detect intruders in a burglar alarm system. So if you step on something, that could detect a burglar coming into a house, for example, and check the weight of an object as well. Gas, O2 or CO2. So these sensors could be used to monitor pollution in rivers or the air, check for CO2 leaks in a power station, and pH. It could monitor levels in soil in a greenhouse. So we're looking at these different values here. Again, monitoring pollution in the rivers. So the sensors are purely just taking readings. Nothing's going to happen as a consequence of of that data that's been captured. Maybe we could plot graphs and compare graphs from what the data was now compared to last week, last month, last year. So the sensors will just take the readings. The next part is, what do we do with these sensor readings? So the role of the microprocessor in control applications. So what happens, so let's say, for example, the greenhouse. I like to talk about the greenhouse. We want to maintain conditions in the greenhouse so we can grow plants at a certain temperature. The sensors will always take the readings, okay, and let's say, for example, the preset value, we want to grow our plants at 21 degrees. Sensors will take the temperature readings and will compare it to the preset value. If the temperature's dropped below that preset, then something has to happen. If it's gone above the preset, again, something has to happen. If it's the same, we can do nothing and the whole process is repeated. So let's go through this. Sensor readings are compared to the preset, which is inputted by the user, so the pre-stored value. If sensor readings are below or higher than the preset value, then a signal will be sent to the actuator, which is the output, to change the physical conditions, and the process is completely repeated. So the input part of this is device or sensors which take the readings. The microprocessor compares the readings to a preset value. As a result of the processing, the computer can send a signal to the output device called the actuator, which will change physical conditions. So let's look at these two examples. So in the greenhouse again, we can compare light, temperature or moisture to preset values. If it's gone too dark, we can turn on the light. If it's gone too cold, we can turn on the heater. Or if it's gone too hot, we can turn it off. If the light is, we have daylight, we can turn off the artificial lighting. Maybe it's gone too hot and we can use the motors to open the windows or to turn on the fans and so on. And if you're having an operation, your vital signs will be measured using sensors, maybe your heartbeat, your blood pressure, your temperature to preset values. A buzzer will be alerted to notify staff if any of these values go below a certain preset value. So obviously, we want a quick intervention if something happens to your heartbeat, blood pressure, temperature. So your conditions will constantly get monitored, and if you stop breathing and something happens, then automatically the doctors and nurses will be notified. So let's now look at the greenhouse in a little bit more detail. So greenhouse automated system. So the advantage is no human intervention is required. Staff are free to do other tasks. Readings can be taken more frequently and are more accurate. The disadvantage is the initial cost of the equipment, ongoing maintenance costs, computer system may malfunction, and humans may become de-skilled. So in the greenhouse, let's look. The preset here is 20 degrees. The sensors are taking the readings. So the sensor we're looking at is temperature. Sensors monitoring temperature conditions continuously. The readings from the sensors are converted from analog to digital. So sensor signals analog converts to digital. The microprocessor will now compare the sensor readings to the preset value. If it's 20 degrees, then the process is repeated. So if the temperature is 20 degrees, that's the temperature we want to maintain. The whole process is repeated. However, if the temperature is more than 20, so it's gone hot, okay, so it's not 20 degrees, the microprocessor will send a signal to the motor to turn on fans and to turn off the heater, okay? And then we will do the process again. We will check to see if the temperature's come down. If the temperature's gone cold, the microprocessor will send a signal to the motor to close the window and then turn the heater on, okay? And then that process will be repeated to check to see if the temperature's come down to 20 or gone up to 20 degrees based on what was going on. So if it's gone too hot, the output is the actuator, and the motor can be used to turn on the fans to cool down the greenhouse. The heater is another actuator, can be turned off. And then we measure, the sensors will measure again, just check to see if the readings have come down and are at 20 degrees. Obviously, if it's gone too cold, then we can close the windows and turn on the heater. And then we just keep monitoring and measuring those conditions to get the temperature to a particular point. Right, some typical exam questions here. In 2019, Cambridge recorded the highest temperature for July in the UK. The data was collected automatically using sensors by a weather station and sent to a computer. Discuss the advantage and disadvantage of using sensors to collect data rather than humans collecting the data. So readings are taken at a more consistent time interval. The sensor reads the data more accurately. Computers can analyze data continuously. Readings can be taken more frequently. Also, it is safer as humans do not need to take measurements. However, sensors can malfunction due to the temperature. This could lead to false readings. The sensors could also be stolen. You could also include in there, maybe sensors could get damaged perhaps. Okay. Maybe the initial costs of purchasing the sensors and setting up the system as well. So a computer-controlled glasshouse or greenhouse is used to grow plants. State-free sensors that could be used in the glasshouse. So you could say light, temperature, humidity, or moisture. And we've come to the end of 2.1. So 2.1, we looked at some input devices, okay? And then we looked at the control systems, how sensors are used in control systems, okay? And in the greenhouse example, sensors will take the readings. It will be compared to a preset. If it's gone too cold, then the output of this system will be maybe to close the windows and turn on the heater. The whole process is repeated. We just take the readings again to check if the temperatures has been increased or not. Right, guys, join me in the next video. We will be looking at 2.2. Thank you for your time. Please drop your comments below. Thanks again. Bye-bye.